Good afternoon, good evening, everyone. Thanks for joining our interactive webinar. I really have the pleasure today to welcome Mark Deverill from Spire Maritime. Welcome, Mark.
Hi, Bart. Thank you for having me. Good morning, everybody.
Okay, so before we start, and it will be an interactive interview-like webinar, I want to tell you that the webinar is recorded. So if you want, you can rewatch it later. We will be taking questions, and I hope we have plenty of time for questions, but please put them in the Q&A. So we will take them at the end of the session. To keep it interactive, we will also have a number of polls. It would be really nice if you can answer the poll. It can help us in guiding the remainder of the webinar. So thank you all for joining again. My name is Bart. I'm CTO at xyzt.ai, and Mark Deverill is here from Spire Maritime. And before introducing Mark, let me explain why we are here. And why we are here? Well, this is basically why we are here. And some of you might be very surprised to see a black screen, but that's actually what is still happening a lot in many organizations. Many organizations are still sailing blind. And what Mark and I will try to convince you of is that you don't have to. You don't have to sail blind these days anymore. Indeed, what if we could really see not only what is happening now, but also what happened in the past, but maybe even predict what will happen in the future? Wouldn't this be nice? And that's really what we will be talking about today in this interview. So we are xyzt.ai. We provide a big data analytics platform specifically focused for spatial temporal data. And as you know, in the maritime domain, there's a lot of spatial temporal data. And one of the very valuable data sources is the data from Spire Maritime. And that's what you see here in the picture. You see a density map of Spire's AIS data in one of our sample projects that you can explore in our platform. So what is xyzt.ai? It's a no-code interactive visual analytics platform for any analyst to extract real-time, but also historical insights. And today we will show also forward-looking insights for maritime and any other data. And we really try to keep it as easy as possible and efficiently as possible for you to do so. With that being said, I would like to introduce Mark. I know Mark for a long time, and I also know, Mark, you've been in the maritime ecosystem for quite a long time already. So maybe you can introduce yourself and explain a little bit what you do at Spire Maritime, what your team does, and basically what you will be talking about today.
Sure. Thank you, Bart. Hi, everybody. Yes, let's get the awkward fact out of the way first. I have been in maritime data for a long time. It's 30 years this year. So clearly I started very, very young, but it's been a very interesting journey. And as Bart said, you know, at the beginning of the AIS ship tracking services story, people were in the dark. Information was very slow to come in. So I am Data Operations Director for Spire Maritime. Spire Maritime is the leading provider of vessel tracking data and information services around vessel tracking and maritime monitoring. I've been with Spire for 6 years, and we believe we provide the unrivaled coverage of vessel positions and movement tracking and the information that you can build on top of that. So we deliver the most accurate and comprehensive data, as you see on the slide here. And I can illustrate that through one of our slides. So I would have lost the share screen.
Yeah, while you are switching the presentation, Mark, you have been using xyzt.ai for quite a long time already. In fact, I think
Yes.
you were one of our first customers, if not the first, for which we're very grateful. So maybe while showing your data, you can explain why you use xyzt.ai. What's
Is
the
my
goal of
screen
it, and
displaying?
how
Ah, here we go. So I didn't hit the confirmation. Apologies. Yes, so we started using xyzt in 2020, I think we realized in recent discussions. And I can't remember how the conversation started, but we realized it was a tool for which we had a need. We had then a very large data set on which we had to do
Mark,
on
I have
demand.
to interrupt you here because I don't see the screen. I see the Zoom app at this point. So
Here we go. Is that better?
there you go. That's better, yes.
Right. So we started using xyzt for exactly the reason of its basic capabilities. We had a very large data set, and we often needed to do our own analysis and investigations on our data set, including visual analysis for particular coverage or where a vessel's journey had good coverage or bad coverage. And it was very geospatial orientated. We could analyze the data numerically, but we couldn't analyze it visually. And the other tools we were using were very restricted in the volumes of data they could display. And what we discovered was that xyzt had a very easy to use, no code tool, as Bart said, where we could load in a complete day or week's worth of AIS data, which is hundreds of billions of records. And then we could analyze it and display it and zoom into it and investigate it and play around with it in the xyzt platform. So what you see here is an example of how we are now using xyzt and have been for the last 4 years. This is one day of Spire's AIS data globally displayed on a map. There's probably about 500 million records from this one day here, because this is all of our partner sources and all of our satellite data. And we can very easily investigate this in the xyzt platform. So that's why we started using the tool, because it solved a real problem for us and it enabled us to perform much more detailed analytics, which we use as both a pre-sales tool and a data quality tool and as an analytical tool. So for us, it's been a very, very useful platform. And we use it in a small team on a daily basis.
Okay. And so what we're looking at basically, I can imagine, is the historical data. Is this something that
Yes.
people can buy from you, this type of data?
Absolutely, yes. So we sell our AIS tracking data through APIs or as historical dumps of data. This is one day's of data from yesterday. So we don't have a live feed into xyzt. We have a daily updated feed to allow us to do analysis on the historical data as it builds up.
Okay.
But this is data that you can access by purchasing the Spire Maritime APIs. Our Maritime 2 GraphQL API is the best example, where you can request on demand the latest information for either the global fleet or a specific fleet or a specific list of vessels or a specific area, and you could get the most recent reports from all the vessels which meet your criteria on the frequency with which you pull data. So you could say, I want global updates every 5 minutes, and you could pull the information, which would then display on a map like this. Or you could do it on demand and say, okay, where is this fleet now? Or where is this fleet? Or which ships are heading to this port? You can call our data through the GraphQL API in very, very imaginative ways to answer the questions that you have. And then what you get is you start to build up a data set which would look like this, the ship's positions kind of globally or within the area that you're interested in. And as I zoom in, you can see there's quite a lot of detail. And what you can do in xyzt is you can scroll through this over time as well. So maybe it's worth us quickly showing that.
And Mark, so I can imagine many people, or at least people in the maritime domain, are starting to use historical data for machine learning purposes. How far back can you go with the data? Is it more than a year that you keep the data?
Absolutely. We don't throw data away. We realize the value of data, and specifically when you're driving machine learning and AI engines, the larger your historical source set, the more accurate your predictions are. And our archive goes back 14 years. Our satellite AIS archive goes back 12 years. And all of that data is available to our customers if you purchase the historical access products. If you purchase the live product, then you see the most recent positions, or if you purchase the raw AIS product, you see the last 30 days as a continually changing window. But yes, we have 14 years of archive data for global AIS.
Very cool. And for the real-time data, how real-time is real-time? I can imagine many people ask you this question.
Absolutely. Real-time is sub 1 minute. So for both satellite and terrestrial-based AIS, and for our dynamic AIS, our vessel-based AIS, the latency is a little bit higher. It's kind of between 7 and 15 minutes. So it's near real-time for almost everything.
Okay, that's really cool. But today, Mark, I think the key topic of today is to talk about some new data products that you have introduced into the market, which are not looking backwards in time, not looking at the current state, but actually looking forward in time. Can you tell a little bit what those two data products are?
Absolutely. We have two. Our first one is what we call our vessel to port predicted ETA. So it's a little bit of a mouthful, but it is what the name says. And this is for every vessel, which we're seeing reports in AIS, so the major vessels with IMO numbers and the cargo carrying vessels. We predict the destination port for those vessels, and therefore the route they would take to those ports and the ETA when they would arrive at those ports. Now, that information is partly transmitted in AIS. Many vessels will say, this is my destination, this is my ETA. What our predictions do is they validate or they improve what's being reported by the vessels themselves. And we find that the ETAs reported by the vessels are quite often not as accurate as they could be, and they change as they get closer to the port. But our predictions of when the vessels will actually arrive are slightly more accurate than those declared by the vessels. And also, if the vessel is not declaring the destination, we predict where we think it's going, looking at the type of ship, its patterns of trading history, where it's gone, where it could go. Maybe what it's reporting and converting a variation of the name into a very clear prediction of where the vessel's going. So that gives us a looking ahead view of things. So as you and I discussed a little while back, Bart, when I said, can we plot in XYZ future positions? So what I'm showing you here is this is data which was taken this morning of vessels with their predicted ETAs and predicted routes. And I've just shown a small sample of the routes to show. And this is, expand this out, you can see these are the routes that we're predicting for these vessels. Now I've filtered this down to a very specific set of data. I'm sorry, this is the wrong window. This is the on-demand routing. This is the this is the predicted routes and predicted ETAs. So these are the vessels where we're predicting the ETAs and the routes. We're updating that every 15 minutes. If you see a variation, we will refresh the prediction for the vessel. Otherwise, we will regenerate it again twice a day. So these are the vessels, and I think I've filtered it here for container ships. So there's a lot of these vessels, and we're predicting where they're going. And now a lot of them will be declaring it. Some of them are not declaring it. Some of them we're predicting variations on what they're declared because it hasn't been updated. So, but what you can see, again, is the future routes. So if I start to expand the timeline of the data that we're displaying, oops, wrong slider, this one here, you can see it opens out, you can see the vessels moving along their predicted routes, and then they all slowly arrive at their ports. So what you can see is where the vessels are going to be in the future. This is the now and a couple of hours ahead situation. And if I slide that along, you start to see where vessels are going to be. But what it means, if you're looking at things operationally, particularly from a port perspective, you can see when the vessels which are expected are going to be arriving in your port. If you're looking at it from a market situation, you can say the cargoes which are on these vessels, and say you're looking at crude oil, or you're looking at iron ore or grain or some other traded commodity, you can see when those commodities are going to reach the destination ports. And when are those commodities then going to be kind of coming into the market trading situation? Or you can see how many vessels are coming to a port and how congested is my port going to be? How busy am I? Are they going to have waiting times? Which feeds into another product we have, which I'm not displaying here, which is our port congestion product, which looks at how long vessels are having to wait in each port by the type, how many vessels are waiting at each time. And if you combine that with the predictions of when other vessels are coming, you can start to get a real kind of performance planning type operational view of things to say, okay, this is the turnaround time. This is how many vessels I had in port now. This is how many are coming. And you can start to see whether vessels are going to have to wait or whether they're going to be able to go into port, or whether and if there's a waiting situation, you can start to plan around that. You can slow down the vessels. Maybe you can, as a port operator, you can start to contact vessels and rearrange the schedule for each vessels to be in port, depending on when you think they're coming. If you're a port operator, you can say, okay, these are vessels due to arrive today. Are they going to arrive today? Or are they going to be late? In which case I can then reallocate their slot to somebody else, contact the vessel and reschedule them. So there's lots of kind of forward-looking operational planning type decisions that can be made using this information.
That's
so we've
really
gone
cool.
from the now situation to the future situation.
Yeah. Sorry to interrupt here, but this brings to mind a question that, as a more tech person I have, is because you are predicting the future, and because time advances, the future today is not the future tomorrow anymore. You can sort of verify your prediction, how accurate it was compared to the real world. Did you do that exercise?
We did. Our data analyst team used the predictions that we're generating, captured the history of those predictions, and then compared them to the actual arrivals of the vessels to see how accurate our ETA predictions were. And generally, it was about 10% more accurate than the ETA predictions transmitted by the vessels. So we were measuring it against the time when we recognized the vessel arriving in a port. We had a set of port polygons through which we create events and recognition of the arrivals and departures from port. And we measured our recognition of the vessels arriving in the port against those which had been predicted as the ETAs in a vessel's AIS versus our own predictions. And we found our own predictions to be more accurate. And they especially became more accurate in the last 5 days approaching the port. And it became more accurate each day as you got closer to the arrival as well. Okay. So we're very confident that it's an accurate and correct prediction that we're generating.
And I understood also that your algorithms or your predictions, they adapt to the changing situations. So maybe not so much for container vessels, but maybe for tankers. I can imagine they change course quite a bit. So you take that into account and you update the prediction.
Yes. Yes. So the engine that generates these predictions is running every 15 minutes, and it looks for a deviation from the previously predicted route. And if a vessel is observed to have deviated from its route, then we regenerate prediction again. And I think that deviation is something like 20 nautical miles off from the predicted route. Then it will regenerate the prediction. So we're looking to refresh at a fairly high frequency, so that we can continue to get up-to-date information.
That's really cool. And this is also accessible through an API?
This is yep. So this is a standard. This is a feature of our Maritime 2 GraphQL API, where you can select the vessel to port predicted ETA feature, and it will become part of your standard response that you can request through the API. So as well as getting vessels' latest position and latest voyage information, you can get the predicted voyage information as well as an add-on feature.
Okay, super cool. Thanks, Mark. Maybe before going to the second predictive product, it's a good time to do a small poll question. So you will see the poll popping up, and there are a number of options. But the question first, what are your biggest challenges in maritime operations today? First option, lack of easy-to-use analytics tools. Second option, lack of accurate predictions of destination and vessel ETA. Third option, insufficient integration with existing workflows. And then the final and fourth option is data gaps in high traffic zones. So please submit your answers. We'll take a minute to give you some time. I see still answers coming in. So we'll wait a few more seconds. All right, I think we are about there. So let's have a look at the result of the poll. Okay, it's a bit uniformly spread. I think the winner is insufficient integration with existing workflows, which is quite an interesting one, which I think APIs can help a lot with that integration. But indeed, it's a bit spread all over the different challenges. So thank you for providing your input. And that brings me, Mark, I think, to the second predictive product, which is called the routing.
Absolutely. Product. So our second predictive product is the routing product. Now that sounds like it might be the same. It's not quite the same because this is an on-demand routing product. So what you can do, you can make a request to our routing API, another GraphQL service, where you can say, if I want a vessel to go from point A to point B, or port A to port B, or point A to port B, what would the route be? How long would it take? And you can put in the normal kind of voyage management criteria for routes, things like I want it to go through the big canals or not. I want it to avoid the piracy areas or not. I want it to avoid the sulfur emission control areas or not. All these variables, and then you can say, what would the route be? And the classic example for that, in my experience, coming from a shipbroking background temporarily, was when you had a shipbroking situation and you want to charter a vessel to pick up a cargo. You look at the available vessels in the market and you say, okay, which ones could get to my port in the window I have to pick up the cargo? And what I've done here on screen is I called our API, and this is for gas carriers. And I've said from their current positions, gas carriers, and these are the ones where we didn't have a clearly predicted destination, which ones could make it to Singapore. So give me the route for all the vessels in the current positions to Singapore, and then that gives you a prediction of when those vessels could be there, and you could select which ones would make it within the timescale that you're interested in. And then obviously you'd have commercial arrangements and discussions with those vessels. So it's very much a kind of forward-looking planning exercise. And for each of these vessels, we've asked the question, we had to make an individual call saying, okay, when would this vessel be able to arrive in Singapore? What would the route be? What would the ETA be? And you can see on the map where the vessels are, and you can see as you scroll through the time when they would be arriving in Singapore. So again, as we did just now, you're looking forward, okay, following the predicted routes, when would the vessels all arrive? And you can see that most of them arrive within the next 2 weeks, and you can use that information to then do the next set of investigations or planning or commercial discussions that you need. So it's very much an on-demand kind of forward-looking prediction utility.
Which you can call through an API, I guess, because it's
again, it's a GraphQL API. You simply say this vessel from here to here, give me the route and the ETA.
That's really cool. Yeah, that brings me maybe to what are like these two new products that you brought on the market. You already mentioned a little bit the use cases in chartering and so on. Do you see other use cases where these products can really add value?
Absolutely. Anything that needs to plan and look forward in terms of where vessels could be, where vessels are, where they're going, and where will they be at a particular point in time. Maybe an example would be if there's a storm in a certain area. Okay, let's look at the vessels on their known routes, and let's just go forward through those routes and say, okay, who's going to be in this area at that time? Who's going to need to divert? Who's going to need to change their plans? What risk have I got? And if there's like a major incident, a tsunami or an earthquake or something worldwide, normally you would look at vessels. Where are they? You know, what's my effective fleet? You can now look forward and say, okay, which vessels are due to come into this area? Which is those operations are going to be affected. So anything where you need to plan around vessels' location over time, this kind of really feeds into that decision making.
Okay, cool. Yeah, I was also thinking about maybe like crew allocation, like I don't know, for maintenance or for inspections or whatnot.
Absolutely, we've had customers who have wanted to look at vessels coming into their service areas, or vessels planning service activity. Okay, where will they be? So then you can plan, you can schedule to have them met in the right ports. I've worked with companies in the past who needed to plan to put people on the dockside to meet vessels, and they had to plan where those vessels were going to be to get the people in the right place to meet those vessels. There's lots and lots of different situations.
Okay. I see, Mark, we also have a lot of questions coming in the chat. So maybe what we can do is I can move on maybe to the next poll. And then I have a little favor to ask from the audience. And then maybe we can go into those questions because I can imagine the questions from the audience are very, very relevant.
Of course.
Okay, so I think let us get up the second poll. So what is your primary interest in maritime data analytics? It's A, enhancing real-time decision-making with live data. So this is talking about the real-time data. B, conducting deep historical trend analysis. So this is talking again about historical data and the analysis. C, including navigational and vessel factors to generate shipping routes. And D, the fourth and final option, is evaluating analytics platforms for better data integration. So please highlight the one that is most appropriate to your case. We'll wait a few seconds again for your input. Okay, here we are. So a lot of real-time decision making with live data, and I think predictive data is enhancing the real-time decision making, of course, and influencing. So that's a really cool, cool statistics to see. So that being said, let me take over the screen for a minute, Mark, but I might expect you to take it over later again if we get many questions. So I'm going to share my desktop, and I have to ask one more favor from the audience. A couple of weeks ago, we introduced a new feature in our platform, which is called Just Ask xyzt.ai. And just to illustrate what it is, before I do my call to the audience, I'm just going to illustrate it with a little demo using Spire Maritime's data. So let me see if I can get in my demo. My screen was not so responsive, so I'll just load it again. It's probably due to the screen sharing here. So I have a number of projects here, and let me open one that I prepared for the webinar. And actually, I had prepared it for the launch of that new feature. So this is historical Spire Maritime data in the platform. It's quite old. It's from 4 years back, but it's just as an illustration sample in the platform. And you see the traffic here in the North Sea, which is quite busy. And so what a lot of our users do is they filter on the data. And they filter out, for example, only certain container vessels like you did, Mark, or tankers or whatnot. So instead of having to set filters manually by clicking around or by coding a little filter, we started using Gen AI, like many do. And with Gen AI, you can do a lot, but we also know Gen AI has its quirks sometimes. And so that's why we are still in beta. And today I want to ask the audience who might be interested in helping us test the beta and getting to better results in the end. But already it's extremely powerful and helpful. So for example, I can now ask questions like, show me all traffic. I'm doing it here in this little filter text box from Port of Antwerp to Port of Rotterdam. And then we will use Gen AI to generate a filter. As you can see here, it generated a filter, which is like a sequential filter of conditions. And you can do it in spatial and temporal domain or in the attribute domain. But I'll do it in the spatial and temporal here. For example, I'm adding taking less than 5 days. And this way you can sort of start drilling down in data in a very intuitive way. And so what you see here now in the end, and let me choose a slightly different visualization. You can start drilling down in the data just by asking. So it's super intuitive and super efficient to do. And it is using a large language model in the end. So just like Mark, you are using AI or machine learning to predict, we are also using machine learning and AI to improve the user interaction and to make it
very good.
more
I love
efficient.
it.
So my call to the audience is, because we are still looking for beta customers, is, do you want to join the beta program? If so, please let us know. I think we have a small poll coming up that asks just you the question if you want to join, or you can scan the QR code on the screen. And it would be really great to have some users in different use cases. We're all in maritime here, but it might be interesting to maybe have some people from, I don't know, the port authorities, or maybe some vessel operators, maybe some intelligence analysts, because it really can give us insights on what to improve and what to add. So I'll wait a few seconds until the answers come in. Okay. Thank you all for providing that. And I think before going into the Q&A, I think the message today was not only to talk about data and analytics, but really to try to make the step to organizational, operational cases. And we really believe maritime organizations should not sail blind. We all know there's real-time and historic data, and now there's also great quality predictive data. we ourselves at xyzt, we are in the business to make sure that people can use the data. Challenges are the data is big, and also it has a lot of dimensions, not only spatial and temporal, but typically also all the attributes and so on. And many platforms have challenges handling that. And then truly what we see is AI is not just a buzzword, it's really transforming many verticals, many domains, and also the maritime domain is being transformed with AI. And you can see it happen in many different areas, in the predictive data, in the user interaction, in anomaly detection, and so on and so forth. So with that, I would like to thank Mark for your time and preparation, and for being a long-time customer as well. And I would also like to thank the audience, of course, to attend in such large numbers. And with that, maybe I can have a look at the Q&A and the chat box as well, because I see questions coming on in both. So yeah, the question about how far back is historical AIS data, I think, Mark, you answered that. 14
Yes, I did. 14 years. We have an archive of 14 years AIS data.
Okay. Next question. About the update rate of real-time AIS data, how much does the distance from terrestrial stations and the position of satellite constellations impact on it?
It does impact it. These satellites are much better at receiving ships' positions once they are outside of port areas. So the two work synonymously together. The terrestrial-based land-based receivers receive vessels very well within their area reception. Once the vessels move outside of those areas into less congested shipping zones, then the satellites pick them up much more reliably. But we also have vessel-based AIS, which also picks up vessels and transmits what they receive. So the three together give us complete coverage.
Yeah, and that's really one of the USPs, I would say, the key USPs of the Spire data is it's just global, it's everywhere. Yeah. Okay, thank you, Mark. Another question I see is historical AIS is great. So many startups are implementing data analytics and raising money. Are we at the peak of AIS popularity right now, or are we at the start? What are your forecasts?
We're clearly not at the start. We've been selling AIS data for 15 years as an industry, and Spire's a story of continual growth of AIS data sales. So I think we're not at the peak yet. More and more companies are learning how to use business intelligence to base operations around intelligence, data-driven decision-making. And I think particularly with the maritime, there's still a long way to go before we get anywhere near the peak. And if you then add in the AI aspect of this as well, the machine learning, AI-driven decision-making aspect, it's an upward path. There's a long way that we can take this.
True. Yeah, I could not agree less. Indeed, if you look at, if we talk a lot with organizations in like shipping companies or port authorities as well, and indeed, even though the industry has been using the data for so many years, I think we're still at the start of optimizing and making everything more efficient and more intelligent using all the data sources that are available. Let's take a few more questions. And there's many questions, so I apologize if we cannot answer all the questions, but we will follow up through email for sure. Next question is the platform support easily fit data into some data model and ready for predict? For example, fit the AIS data to a random forest and do predict with the UI. So that might be a question for xyzt, but I'll answer that quickly. The xyzt platform by itself does not do predictions on the data. So in this case, the predictions are done by Spire Maritime, and Spire, Mark, you are selling those predicted data products. Huh?
Yes. And you, as I said, you can access those predictions through an API, through a set of filters. So you can narrow down on what it is you're asking for as well. So you make your own requests for what you want through the APIs.
Yeah. And I think both of our organizations, we can, of course, help for any custom type of analytics if that is needed. I see a question here. Can xyzt.ai assist in analyzing historic movements of vessels to identify dark trade, such as unusual STS, AIS manipulation, etc.? Yeah, the short answer is yeah, of course. And it's one of the key use cases why people use the xyzt.ai platform. It's used in many cases. For instance, also in Nigeria, where there's a lot of oil theft, unfortunately, for the country. And there, indeed, by basically cross-checking AIS data with port reports, authorities could recover a lot of lost taxes. Question for Spire, for you, Mark. Does Spire use ocean carrier container vessel schedules as a data source for your predictions, in addition to the historical data?
Not at this point in time. No, we don't.
Okay, so maybe something for the future. Let me see. Let's take a couple more questions, and then we can probably round up. How many AIS satellites does Spire have? Is a question. You know that, Mark? Can you still follow?
Oh, crikey. I do not know the exact number of our AIS-enabled satellites. We had the ability to swap satellites in and out of service. We had 2 constellations. We had the real-time satellite constellation, which is pretty much fixed at around, it's just under 60 satellites collecting the real-time satellite data every day. The number in the second constellation changes, and I don't have the exact number to hand right now. With Spire as a company has launched over 150 satellites in the last 12 years, and they had a 4 to 5 year lifetime generally, so they come in and out of service. But I don't have the exact number to hand. We focus more on the volume of data that's being generated as part of the service.
Okay, cool. And maybe an anecdotal question. Is it true that satellites are named after employees at Spire?
Yes, there's one up there called Lima Detheril. Yeah, we each get a name of satellite. So if once you join the company, you get onto the list, and when you get to your point, when the satellite is launched, you get to name it.
That's really cool.
It's a nice little feature.
That might bring some people to the company. That's really cool. Let's do 2 more questions. So, question maybe for both of us, but I'll start with you, Mark. How do you see the increased connectivity impact this whole maritime awareness?
Well, increased connectivity is perfect, because decision making is all about how quickly you can get information, how quickly you can use that information. So particularly with our vessel-based AIS, where it's using satellite comms to transmit that the data back to us, we're getting that there quickly. So we had the real-time data within 1 minute from the real-time AIS satellites. We had the vessel-based AIS within kind of 6-7 minutes. It really enables their quick processing of data, and therefore quick decision making. Yeah. I think it's critical. In the past, prior to AIS, data was coming in, on a daily basis, and it was much slower. Now we have the ability to make real-time decisions with real-time data.
Okay. Yeah, I think I totally agree, Mark. For us, it's the same thing. I think the increased connectivity at sea is changing the maritime domain. But we also see, aside from AIS data, we see a lot of custom sensor data being transmitted and collected, and also even environmental data on the current state of the ocean and becoming available. And yeah, we have customers that ingest that data together with AIS data into our platform to be able to analyze all these parameters as well. And then let's take a final question. Let me see here. What about, this question. So what if there is no AIS data? What if the vessel turns off their AIS? I guess that's the question.
That's a very good question. We have a partial solution for that.
Okay.
We are using radio frequency geolocation data to recognize transmissions of AIS messages without a GPS position. So vessels will often try to hide their location by turning off the GPS connection in AIS, or by spoofing the position information within AIS, and we can detect when that's happening. Through the radio frequency geolocation, we can detect where the AIS transmission came from. and therefore whether that's from a vessel where it's saying it's somewhere else, or whether a vessel's saying I don't have a position, and we can tell that. Not globally, it's in the early kind of phases of the product development, but certainly for vessels at sea, we can pick that information up, and through the radio signals received by the satellites, we can identify such things. If the vessel goes completely dark, then there are other services which are being worked on to try and kind of correlate ships that could be in reported positions. Other companies are correlating recent AIS with imagery and things like that, satellite aperture radar imagery and things like that. So there are services developing, but I don't think there's a complete service yet. But we're part of that solution going forward.
Yeah, there's a lot of interesting activity in that domain, and in the end, it's also spatial temporal data. It's location and time and some attributes maybe. We've also seen this data in our platform already, Mark, and we've also seen SAR data from satellites collected to do these types of analysis. So definitely for sure, if there's no AIS data, it can be an interesting sign to investigate. And indeed, gaps can be, of course, seen from the AIS.
And the classic one with a SAR observation is the question is, okay, which vessel could it have been? And you can use like the routing predictions. Okay, which vessels from their last reports could have got there? Could have been this vessel. SAR will say, oh, I've got maybe a 250-meter long vessel. Maybe you can tell it's a tanker or a bulker. Which bulkers could have got to there?
Yeah, that's really cool. So it sort of reduces the search space. It's like searching for a needle in the haystack anymore. Okay, cool. I think we took our time. We handled a lot of questions. For those that we didn't handle, we will follow up through email. So to conclude, I would like to first thank Mark. Mark has been really dedicated to preparing this interview very well, and it's a real pleasure to have this vast expertise shared with all of us. I think and I hope we all learned something today. At least I did. And with that, I would also like to thank you all for joining the webinar. And of course, it has been recorded, so you can always rewatch it or share it with your colleagues. So with that, thank you, Mark. Thank you, everyone, for joining.
Thank you, Bart.